See, one more point I would like to say here. This OP line segment makes some angle with x-axis, right? With the in the positive direction. I already told you anti-clockwise direction is positive direction. That means here the vector OP is doing some angle with the x-axis and also with the y-axis. Yes or not? Yes. Now, let us see when you have a point in a three-dimensional space. What is a three-dimensional space? It looks like, see, x-axis we have here and y-axis we have, and another dimension with the to mention the dimension we'll use x-axis. And suppose you have a point here. You have a point here, and let us say the point as P, and it has three coordinates: x coordinate, y coordinate and z coordinate we have. If you join that line, that OP, right, OP vector is denoted with xi plus yj plus z, another vector we are taking k. And can you tell me what is the magnitude of OP? Under square root of x square plus y square plus z square, right? And definitely it makes this OP line segment makes some angle with the x-axis, right? And also with the y-axis and also with the z-axis. I am letting these angle as alpha, beta and gamma, right? See, let us see how it looks like in a real picture. See, this is a three-dimensional box you have here, right? It is a rectangular box we have here. What is the what do you call this? This is a cube, right? See, this is a cuboid. This box is what? This box is cuboid, right? If all sides are equal, if you consider, that is cube. This is a three-dimensional figure of rectangle. Its two-dimensional figure is rectangle. This is cuboid. See, if you have a point here, suppose here we have a point, right? Then we are joining origin to that point. Suppose my point is here. This is my point. Suppose I am joining origin to, this is my origin, beta. This is my origin 0, 0, 0. If I join that point to origin, then how does it looks like? See, when you have this picture, you imagine this one, and any room's corner also you can imagine. You are holding a stick from the corner of the room, suppose. You can imagine that picture. See here, this line segment O to P. This is making some angle with our x-axis and y-axis. See, right? It is making some angle with y-axis and x-axis and z-axis also, right? Right? Is it making or not? Yes, that angles I am considering here. See, this picture always looks like this, ma. You imagine this, right? You may have this line to this side or this side, that side, right? Here you can observe three planes also, right? This plane is called as this plane. See, this is xz plane. Here you have what? Xz plane. This plane is xz plane, and this side is xy plane. And here yz plane you have here. You can place any two-dimensional objects in plane. For example, you can place a circle on a plane, any side of the plane, right? But to place a ball on the plane, is it sufficient? No, we cannot place the three-dimensional object in plane. We need more than that. That is three-dimensional space we want. So in space, this is covering this space. In space, we can measure the properties of this ball, right? Now, Okay, let us see this, let us continue this. That means what? If you take any line segment from origin to your considered point P, it is making definitely some angles with the x-axis and y-axis and z-axis also, right? That are I am considering as alpha, beta, gamma, right? Alpha and beta and gamma are the angles which are made by the line segment OP with the x-axis and y-axis and z-axis. Imagine that figure. And let us apply the cosines of these angles, that is cos alpha, cos beta and cos gamma. These are generally we will take it as L, M, N. These are what? Direction cosines. Direction cosines. Got it? These are direction cosines. And the property we have here is L square plus M square plus N square is equal to 1. That is cos square alpha plus cos square beta plus cos square gamma is equal to 1. And LMN represents what here? Direction cosines. That means if you have a line, if you have a point P in the space and the line joining OP makes some angle, or else you can say the vector OP makes some angle with the, can you tell me the magnitude of this vector? That is under square root of x square plus y square plus z square, right? Right. So this vector OP makes some angle with x-axis, y-axis and z-axis. The cosines of that angles are directional cosines. And now let us talk about direction ratios. Direction ratios. See, if I extend this line, what happened? If I extend this line, the angle won't change, right? What will be changed? Suppose you have a point here P, A comma B comma C, suppose. If I extend this line also, there is no change in the angle. The change happening in the length of the vector, right? So, for what values of A, B, C, we don't know that A, B, C, but for such values of A, B, C, we get L by A is equal to M by B is equal to N by C. Such, that means what? Equal ratio you are getting. Such values are direction ratios here. We call A, B, C are direction ratios. This is a point on OP, right? And L by A, such that L by A is equal to M by B is equal to N by C. These are what? Direction ratios. That means if you have a point P, A comma B comma C, if you have a vector AI plus BJ plus CK, then you can say that A comma B comma C are what? Direction ratios. If you know the direction ratios, you can find directional cosines. How can you find out? Suppose this is a point P right here. You drop a perpendicular here. Then what do you have here? This is, I am considering angle alpha. On x-axis the length is A, right? On x-axis the length is A and this length is B. And here this length becomes A square plus B square plus C square. You write from the right angle triangle, what will be cos alpha? Cos alpha is equal to what? Adjacent by hypotenuse, right? Adjacent by hypotenuse, that is A by under square root of A square plus B square plus C square. Similarly, cos beta is given by B by under square root of A square plus B square plus C square. Cos gamma is given by C by under square root of A square plus B square plus C square. These are nothing but what? L, M, N values. This is the relation between directional ratios and cosines. If you know directional ratios, you can find directional cosines in this way. And suppose you have two lines here. This is a point O, P, Q. This is suppose A1I plus B1J plus C1K vector and A2I plus A2J, sorry, B2J plus C2K vector. Suppose there is an angle theta. That means these two are two different vectors. OP and OQ vectors, then how do you find the angle between these two vectors? That is given by cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 by under square root of A1 square plus B1 square plus C1 square into under square root of A2 square plus B2 square plus C2 square. Here A1, B1, C1 are the directional ratios of this OP, and A2, B2, C2 are the directional ratios of OQ, and we can take L1, M1, N1 are the directional cosines of OP, and L2, M2, N2 are the directional cosines of OQ. Then if you know these two directional ratios, if you know, you can find this theta by this formula. And if you know directional cosines, you can find the cos theta by L1 L2 plus M1 M2 plus N1 N2. These two are very important. See, suppose these two lines are perpendicular, then what about the angle? This is 90 degrees, right? Same lines, but they are perpendicular to each other. That means what? Angle is 90 degrees, right? That is theta is 90. What is cos 90 value? Cos 90 value is what? 0, right? So what do you say? Cos 90 value 0. So whenever two lines with the directional cosines L1 M1 M1 N1 and L2 M2 N2 are perpendicular, two lines with these directional cosines are perpendicular, then they have to satisfy L1 M2 plus M1 N2 plus N1 N2 is equal to 0. This is also important thing. These are the basics of directional cosines and directional ratios. Let us do some problems.